Hello, welcome to the final episode of Introduction to Operating Systems and Virtualization. My name is Scott Neal. Today we are looking at virtualizing applications. In previous episodes, we have looked at operating systems in general. We've looked at virtualizing those operating systems, but ultimately it all boils down to the applications. So today's lecture does focus on application performance in a virtualized environment. So we're going to be looking at application performance. We're going to be looking at differentiating between different types of performance optimization strategies. We'll be defining some terminology associated with application virtualization like containers, vApps, and virtual appliances. And we'll be examining how applications are packaged in virtual environments. Ultimately, as I said, the underlying reason we build any kind of a server, whether it's a physical server or a virtual server, is to run some sort of application. And for the purposes of our discussion, applications are programs or groupings of programs that we design to provide some sort of service to their users. Things like databases, web tools, word processors, sales, marketing software, they're all used to increase productivity and revenue for the business. So it goes without saying that if you have an application that's running and it's running poorly, then your users are not going to be using it appropriately and you're not going to have buy-in from your organization on that application, and it will have a very short lifespan. So what can we do to improve application performance? Well, one of the things that we can do is look at virtualization as a means of providing a more reliable environment for our applications. This is really something that you have a lot of difficulty getting buy-in from administrators. Administrators, of course, are often reluctant to virtualize application environments. Administrators don't like change. Change to an administrator is kind of a scary prospect. If it's not broken, they don't want to have to fix it again, and they have their time is very valuable. They're usually trying to manage a network, trying to troubleshoot and do a whole bunch of things. So virtualization is just one of those things that really takes a little bit of research and really takes a little bit of planning before they can actually implement. So consequently, they tend to be more afraid of trying this new technology. But rest assured, virtualizing applications and operating systems is coming to an organization near you. A lot of organizations have already begun to adopt virtualization, and usually once you get into it and you begin to see the true benefits of virtualizing your operating systems and your applications, you really have a hard time turning back. Virtualization, of course, offers many of opportunities to improve availability, performance, and security. For instance, VMs can be reconfigured easier than physical counterparts. They're much more scalable. They tend to be much more flexible. So I want to go over some strategies for you today that may assist you when it comes to virtualizing applications. Probably one of the best examples of technology out there that really caters towards virtualizing applications is VMware's ESXi solution. It is an industry leader in providing the easy-to-use resource management utilities. A lot of other vendors are beginning to follow suit with this as well. So don't just think of ESXi as the only solution out there for virtualizing applications. Most vendors are in the process of or have already adopted some suites of utilities that really do give us some availability and performance options. So there are three methods of configuring memory and CPU usage, two items that we really do like to tailor and optimize when we're talking about employing applications and operating systems in the virtualized world. One of those is shares. Shares really allows you to measure CPU and memory usage relative to the other virtual machines as a method of resolving any kind of contention for shared CPU resources out there. So the way this works is that if you set up a share, a VM that has more shares is going to be entitled to more CPU time respectively. Another option available that you can configure is reservations. Reservation setting really guarantees a minimum amount of CPU memory resources. So even if your CPU contention is at its highest point, the reservation is going to ensure that it will not reach that minimum amount. Last but not least, limits. I can also set a limit that's going to represent the greatest amount of that resource which I want allocated to the VM. So a lot of these settings you're asking yourself, well, how do I know what to set what? Well, this really boils down to the criticality of the application that you're running in that environment. So another tool that I like to use is resource pools. Resource pools are really used to allocate shared resources in a virtualization cluster. I can not only apply this to multiple hosts in the cluster, but it also works on single host environments as well. And the way this works is it looks at aggregated CPU cycles in memory and then reserves it for groups of virtual machines or users. Nice thing about resource pools is that I can dynamically alter it, I can subdivide it. That gives me a lot more granular management. In this particular example here, I have two resource pools. I have a maximum capacity 41.6 gigahertz, 128 gigabytes of memory. My two resource pools combined still leave me with a capacity in reserve of 7.6 gigahertz and 48 gigs of RAM. Meanwhile, those resource pools, and it doesn't matter if those pools consist of multiple physical boxes of the total cluster or on a single box, I know that I have those resources reserved in a sense for each of those pools. Some other optimization strategies if you're thinking about virtualizing applications that may be beneficial. We talked about live migration in an earlier lecture. Automated live migration does give us another opportunity to provide good load balancing during points of high contention. So VMs are going to be moved from one machine to another so that if, say for instance, I have a machine with 3 or 4 VMs on it, I have a machine that's listed as a critical infrastructure machine that's beginning to lose performance due to resource starvation, then automatic live migration is going to move the remaining VMs over to my other clustered resource that will free up resources on that machine and improve the performance of it. Another tool available to us is something called VM Affinity. VM Affinity is going to be used to guarantee that two virtual machines will always be on the same host. So why is this a good plan? Well, if I have high rates of data exchange that need to be dependent upon, say I have a database server and an application server that are sharing data between each other on a routine basis, I may opt to want to keep those on the same host environment to improve the data exchange rate. If I am more worried about VMs, resource contention between two VMs, I may opt to use anti-affinity. Anti-affinity is going to do just the opposite of VM affinity. It's going to ensure that no two VMs will reside on the same host. So if I have two critical application environments that are sharing host resources and they tend to contend for those resources, I may opt to use anti-affinity to ensure that they are not going to be migrated onto the same host at any time and therefore create a contention issue with the resources. Also, quality of service capabilities, or QoS, is really a storage, I/O control, and network control will help to ensure that all the applications are going to receive adequate resources on the box. Another option, another tactic that you may want to use is something called 3-tier architecture. When we talk about architecture or tiering architecture, we're really looking at a client server model where each tier or layer is going to be run and managed separately. There are some decisive advantages to this type of architecture. Certainly 3-tier architecture is not the only tiered architecture out there. There's 2-tier architecture, 1-tier architecture, but a tier really is going to represent either a presentation layer, a business logic layer, and a data access layer respectively. And this is particularly true in a 3-tier architecture layer setup. In addition to using a 3-tier architecture layer setup as illustrated here, we may also want to ensure that we use virtual firewalls. And virtual firewalls are going to allow me to protect my VMs from malicious intrusions. So we can also incorporate virtual firewalls in addition to any other security apparatus that we may be running on the network. Virtual networking components further are going to isolate the VMs from the physical layer. So as you can see in this illustrated example, I have an application server, I have a database server, and I have a web-based server that I have set up as a three-tier architecture. And the application server and the database server are set up with an internal virtual switch. The internal virtual switch not only isolates it in some degree from the host environment, but it also provides a very, very fast way of exchanging data between each other. Then that application layer or application server may take or parse information and send it to the web server. The web server has made a request. That request is on the web server and behind a DMZ or demilitarized firewall there, and so it gives us an isolated instance of the web server that is even further going to protect the infrastructure management application server and database server environment. Once that web server has parsed out the request, it will send the data through the external virtual switch to the physical NIC to the internet. There are some big benefits to using a three-tier architecture system. First of all, each one of these tiers, the web server, the application server, and the database server, can be adjusted independently. I also have the ability to use page sharing, which is going to allow for better resource utilization, and I can use things like templates, clones, can all be used for deployment. And these boxes are going to be easy to deploy since they are broken down and separate. I can use tactics like live migration to ensure that I have no resource contention among any of these three servers. So if I have an application that's been virtualized, I want to ensure that it has performance. What are some means of making sure that I have optimized that performance on that application? Well, for starters, I can deploy enough resources to meet the application's demand. And that's going to mean that I need to understand that application, how it works, and the overall need for that application from the user perspective. I'm going to have to gather some usage metrics on this as well. I'll have to do it on a regular basis so that I can adjust my strategies as needed to account for any increase in demand. I can also turn on and use dynamic configuration strategies that are available in my virtual environment. I can also, if anytime I have some sort of a performance issue, I need to start looking at bottlenecks, trying to identify bottlenecks that will decrease the overall performance. Some questions I could ask: is that bottleneck on the physical side of the environment, or is it on the virtual side of the environment? Are the VM resources managed properly? Can I use some more optimization strategies to ensure that there's no contention between two regularly used servers or operating systems or applications that are vying for each other or need each other or dependent upon each other to service a user? So these are all questions that I can ask as far as troubleshooting the application environment. In addition to setting up, maintaining, and running your own applications, I do have another option. I can go out and I can find pre-built, pre-tested virtual machines that can already contain everything I need to deploy the particular applications I'm looking to deploy. Some are even specially architected with a very small, minimized, optimized operating system. We call this JUICE, and that deliver only what the application requires, leaving us with a very streamlined operating system, a very small footprint, very small for security footprint. They tend to be faster and easier to deploy or upgrade because I really don't, anytime there's an upgrade that comes out, I don't have to worry about upgrading the box. I just take it out, I put in the new one, and it started up. I don't have to worry about patching it. I don't have to worry about updating it. I just wait for the next update to come out. I remove the old one, put in the new one. VApps are another option. They are packages of VMs that make up an entire application deployment. A lovely tool to use if you're looking for, these work very well, particularly for vanilla type of applications that are widely distributed that you can make use of. Another term that you keep hearing about from time to time, is definitely a buzzword in today's environment, something that Server 2016 brags about, is containers. In a traditional hypervisor-based virtualization, All the isolated processes and machines are going to have their own operating systems. They're all going to run independently from each other on a hosted environment. However, if I'm running a container-based environment, those individual instances are going to share the same operating system. That operating system in turn is going to run multiple what we call user spaces or user space instances, which are isolated from one another. Nice thing about this is that each container is going to hold the entire runtime environment. That's going to include binaries, the libraries, all of anything that's needed to ensure the application is running and up for the users. Now there are some benefits to running containers. If a container goes down, it's an isolated environment. It's not going to bring down the operating system. All the other containers should be able to run independently of that instance. Containers are very easy to deploy, and so you see container, particularly if I'm going to be running a particular instance of an application for multiple users, multiple clients, setting it up in a container environment is certainly a viable option for me. Containers are going to be typically and generally accepted as not as secure as virtualizing an entire virtual machine, but they are much smaller and they're much more efficient to deploy. All right, this is our last lecture, so let's summarize. Understanding your application resource needs are a very important factor when doing a successful application deployment. By understanding the needs and the user needs of that deployment, I can ensure that I've allocated enough resources and turned on enough resource strategies to make sure that there is no contention for the resources for that virtual machine or application. Virtualization can provide applications in virtual machines with more performance options that meet or exceed physical servers. Definitely true 99% of the time. There maybe are a few instances where I could think of I wouldn't want to run a virtual application, but it's few and far between. Configuration options, things like shares, reservations, and limits are all designed to help me ensure that all of my critical virtual applications have priority at times of high resource contention. And if I'm not comfortable building out an application and virtualizing it, no worries. Chances are you can find a prepackaged virtual machine with that application pre-configured or as an optimized virtual appliance that I have the ability to deploy very quickly, which will further maximize my efficiency and reduce costs. I hope you've enjoyed this lecture series, Introduction to Operating Systems and Virtualization. For my students, it's a true introduction into the world of IT. And it gives them an opportunity to touch a wide variety of operating systems before they move on to more courses in our program. For you viewers out there, I suggest maybe you take a look at our server lectures, see if you're interested in doing some server administration. I hope you've enjoyed it. I look forward to seeing you again soon. Have a great day.